Good evening. Good evening, all. Rajesh sir, good evening.
Yeah, good evening, ma'am.
Yeah, you can start the sessions.
Okay, ma'am. Done. Well, guys, hope I'm audible. And the screen sharing is also working. Just drop a hi in the chat box. Good evening. Good evening. Right. So everything is working fine, right? We can get started. Yeah. Good evening. Right then. So see here today we are going to get started with functions. Okay. We'll talk about functions. Yeah. Just a second. We'll talk about functions. We'll go through what is time complexity, what is space complexity. Sorry. What about, I'll go through recursion and all. Just a second. Let me fix this. Yeah, this is will be done. So today is day 4. Let me create a new file for us. Day4.py it is. Now see, coming to functions. Coming to functions. Now, what is a function? Any idea? Any idea about function? Any idea? What is a function? What is a function? Any idea? Very good, very good. Function is a block of code which will be called, okay, so which will be executed when it is called upon. Done, done, done. Perfect. Okay. Now see here, if I have to talk about it in a very simple manner, since we have a lot of beginners as well, function is something which performs a task. Let's say, what is a function? Function is something, something which performs a task. It will complete a task for us. Okay, that's it. For a low level idea about it. Or if you want to go with the technical definition, you see a function is a block of code. Function is a reusable block of code, you can say. Reusable block of code which will be executed when called upon. Okay. When you call the function, whatever block of code that you have written there, it will be executed. The main objective here is to reuse the block of code. Okay, reuse the same block of code. Done. That's it. That's what a function is. Let's pop your chat box out of it. Yeah, done. Right. That's it. That's about function. Now let's see. Let's go with some examples of function. You see, we have been using print. Print is a function. What print will do? Print will display something on screen. Okay. Display something on screen. We have input. What input will do? Input will take some input from the user. We have int. It's also a function. Okay. It converts the given integer, like the given string into input, right? That's like integer. That's what we have. So print we have, input we have, int we have all these functions which are doing some task for us. Now there are two types of functions. First one is predefined functions or inbuilt functions, you can say. Predefined. They're already defined. Defined by you and me, someone, okay, the developer. So see, so predefined functions we have. These they already come up with Python. Now, second one is user defined. User defined means we are users. We are going to define them. So user defined we have. So predefined functions, what are the example? This print is example, input is example, okay, int, etc. These are all example. Done. User defined functions, we are going to define them. So that's what we are going to do. Let's write our own function. Before we get started with it, you see, there are four parts of a function. There are four parts of a function. We have two mandatory parts, we have two optional parts. You see, the first part that we have is we need to define a function. You see, function definition. The second part that we have is function call. These two are mandatory. Mandatory. These two are mandatory. Now coming to the optional parts, you see, optional parts. The third point is we have something called arguments, or we call it parameters. Next, fourth one, we have something called return keyword. Okay, we have return. So four main parts of function: mandatory are function definition, function call, optional are arguments and parameters. Let's go through them. Let's get an idea about it. Okay, let's go through them. So see here, coming to the definition of a function. Let's say I'll write some small statement here. You see here, hello, I'll be writing. As you all know, these are all comments, multi-line comments. So my program will start executing from line number 25 onwards. So if I run this, I should be getting hello. Okay, pretty simple, pretty easy. We all have done this, done. Now what I'll do is I'll cut it out. Okay, I'll write something called DEF. DEF stands for definition, def. With a single space, you can come up with the name of a function. So name should be a valid identifier. Now what's a valid identifier? It should not contain any special character apart from underscore. It should not start with a digit. Okay. These are all the things. You know what's an identifier is. So it should be a valid identifier. Let's say the name of the function is do something. This is the name of the function. After the name of the function, go with open parenthesis, close parenthesis. That's mandatory. Then go with a colon. Now, if you click on enter, you'll automatically get an indentation. With a level of indentation, whatever statements that you want to write inside the function, you can go with that. You can start your code block. Okay. Let's say I'll go with a single line here. Hi, I am a function. I am a function. And I'll go to the next line and you called me. That's it. That's it. You see, I have a small habit of separating the function area and the main area. You see, I'll be just using a single dotted line, commented line here in this manner so that it will be clear for both of us. Okay, now see here, what did I do? DEF, definition, name of the function, open and close parenthesis, colon. With a level of indentation, I have written some block of statements here. Done. That's it. That's what we have. Do something. Now you see here, earlier when I ran it, I got that hello. Now see, this time I'm going to run it. Okay. See, I'm not getting any output. Why? What's the reason? I'm unable to see any output. What's the reason? What's the reason? You see, I wrote two print statements here. I'm trying to run it, but this time I'm not getting them. This time I'm not getting them. Okay. Yes, you see, as I told you, mandatory parts. Function definition is one thing. Now coming to the second one, function call. Doesn't matter how many functions you have, how many lines of code you have. You can have thousands of functions. You can have thousands of lines inside of them. Until and unless you call a function, it will never be executed. Or imagine, when you write print statement, then only something will be executed. Na? When you write input, then only it will wait for you to enter some input, right? So you are calling that function. You want that to be executed. So this is a function. This is a piece of code that I have separated. I have given a name to it. Now, whenever I want to execute it, I just need to call it by its name. So how? What's the name of it? Do something. How to identify something? Through the name identifier. The name of the function is do something. Just call the function. Open and close parentheses. This is what we call as function call. And see this one. This is what we call as function definition, or particularly this first line is what we call as function header. Okay. A body of the function, function header, it all. Okay. That's what we call as function definition. Done. Done. Very good, very good. Perfect. Right. So see here. Now see, I'll be running it one time. I'm getting the output. I've called the function. It's been executed. Done. Imagine I have some 1,000 lines here. Okay. And these 1,000 lines, let's say I'm writing a very big code also. I need it at multiple locations. Multiple times I wanted to execute these 1,000 lines at multiple locations. I'll not be able to write a loop for it because it's not continuous. They are all at different places. Okay. Imagine it has 1,000 lines. I cannot write 1,000 lines and show that to you now. That's fine. Okay. So the solution is you only have to write it once. Write it once, name it as a function, separate it, just cut out this code, give it a name, keep it somewhere. Now, whenever and wherever you want to execute it, you just need to call it by its name. That's it. That's how simple it is. You see, in programming, we follow a principle. We call it dry principle. Dry principle means do not repeat yourself. Do not repeat yourself. Okay. Whenever you're writing a piece of code, you should always reuse it. You should always reuse it. So in a function, you see, this is very simple. If you are struggling with functions, it's dead easy. It's the easiest topic. Okay. So see, function, what you will do, or a simple note point or a general view. Okay. General note, I'll say, or something, general view, something. Okay. Separate a piece of code, give a name to it. Okay. Give a name to it, call it, call it with its name, whenever, whenever you want those block of statements. Let's say I'll make it a bit formal. That's it. See, very simple. Whatever block of code that you're writing, just separate it, give it a name, DEF, give it some name, keep all those statements here. Whenever and wherever you require it, call it. You say I'm calling it one time. I'll copy it. I'll paste it again, paste it again, paste it again. So how many times I'm calling it? 4 times. How many times will it be executed? It will be executed 4 times. You see, did I write it 4 times? No, I'm calling it 4 times. Imagine we had 1,000 lines. I don't have to write all 1,000 lines again and again. I just need to call it. I'll be able to get it multiple times. Okay. This is what we call as code reusability. And this dry principle is one of the golden rules of it. Do not repeat yourself it is. Okay. Understood, understood this basic part. Everything is clear. Can we move on to the next step? Can we move on to the next step? Everything is clear? Done? Done? Right, perfect. Now see here. Now let's write factorial program. Yesterday we have all seen it, so you all already know about it. So n is equal to int of, okay, input. I'll ask the user to enter an n value. User will enter an n value. Done. Perfect. Very good. Now fact is equal to 1 for in range of 1 to n values I have to generate. So starting from 1, n plus 1 because that is exclusive. So I need to take one value extra. It will end at 10. All the numbers from 1 to n will be generated. Fact is equal to fact into I. Yesterday you have seen the animation as well, how this generally works and compounds. Once we are out of the loop, once all the calculation is completed, I'll come out of the loop. I'll go ahead and print fact. That's it. That's how easy it is. That's how pretty it is. Now, this is the factorial program. Now let's run this. You see here n value equal to 5 I'm giving. Factorial equal to 120. If I run it again, 7, 5, 0, 4, 0, 6, 720 we are getting perfect. This is factorial working fine. Now let's imagine it's free only, right? Let's say I had some 10,000 lines of code also. Okay. In those 10,000 lines at random locations, let's say 234, 5675, okay, at some random locations, I wanted to execute factorial. I need factorial. If I write factorial multiple times at these locations, I'm not following my principle. And why should you write it? You have written it once, you have to reuse it, right? So what we will be doing is, as I said, as a general view, what do you have to do? Separate that piece of code, give a name to it, wherever you want to execute it, call it. That's it. That's how things will be done. You will be able to reuse the same block of code again and again. That's the main usage of a function. So DEF, start with definition, space, come up with the name of the function. So what's the name of the function? Name of the function, I'll be keeping it as factorial only. Okay. Factorial, open and close parenthesis, colon, with a level of indentation. Whatever statements that you wanted to write, keep it inside them. You see, they all should maintain the same level of indentation. You see, same level of indentation. Done. Everything is perfect. Now, I generally like to separate the function area and the main area. That gives you a lot of clarity. You also try it out. You will be addicted to it. So here, indication, my function is completed. That's a separate area for me. Done. Now again, you guys see, I'm trying to run it, but I'm not getting any output. Again, why? Why? Why I'm not getting any output? Why I'm not getting any output? Why I'm not getting any output? Again, I want you to answer. Yes, we need to call it. Do remember, until and unless you call a function, it will never be executed. You see how to call it? What's the name of it? Factorial is the name of the function. That's it. If I call it, factorial function will be executed. All this code will be executed. Let me try it out once. Let's run it. And value equal to 5. Factorial 120 we got. I'm going to call it multiple times. You see, 3, 4, 5 times also. If I run it again, if I enter in value 5, if I enter in value 7, if I enter in value 9, if I enter in value 4, you see I'm getting all the values. I've called it 5 times. It calculated factorial 5 times. Did I write it 5 times? No. So, what is a function? What do you do? Function is something which performs a task. Here, factorial is a function which is executing factorial. Function is a reusable block of code which will be executed whenever you call it. Okay? And user-defined function, we are writing our own function. What are the two mandatory parts? Function definition, function call. Okay, you need to define a function, give a name to it, write some code block. You need to call it in order to be executed. Okay, so that's what we have, function definition, function call. Now, what are the optional things? We'll get into that. First, let's see a little bit more here. Now, let me show you how everything actually works here. Okay. Then I'll be asking you if you guys have any doubts. Then we will talk about it. Otherwise, we'll go through arguments, parameters, we'll go through return keyword. With that, we will be done with it. And we will be going through recursion. Recursion, I just love it. So you will also do after today's session. Now see here, what happens is my program execution will start from which line? My program execution will start from line number 50. Line number 50, what I'm doing? I'm calling my function. Okay. So it will go to line number 43 where the function is present. It will execute all the lines and it will again come back to this calling line. Okay. You might ask, sir, why it should again come back to the calling line? Because we have other statements after it not to be executed. So it need to come back. It will come back to line number 50. It will execute the other lines. Now see here, line number 51, what I'm doing, I'm again calling the function. It will again go back to line number 43 where the function is kept. It will execute all those lines. It will again come back to line number 51. Now same process will keep on repeating itself. So what you need to understand is whenever you call a function, the control will come to the line where the function is present. It will execute all the lines of the function. It will again return back to its calling line. Okay. Clear? Clear? Understood this word? This is okay? These statements are very important for you. If you just go through these statements properly, you will understand the entire function concept. This is okay? This arrow marks and all is fine? Done? Understood? Clear? Any doubt? Any doubt? Come on, guys. I need good response from your side. Keep the energy high. Done? 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 Now see. Can you repeat? So see what happens is when you call a function, where is this factorial function present? Where did you write all the code? We have written all the code in line number 42, 43. Whenever you call it, our control in the sense your code will be executed from that line until the end of the function. End of the function is 48th line. Once all the lines of a function are executed, it will again go back to which line it was called. It was called on line number 50, so it will again go back to line number 50. Okay, that's what it is going to do. Done. Now see, now this is another important point. Now this is what we call as function area. This is what we call as main area. Okay, main area. Let's say this is, I hope you all might have seen any science fiction movie, Marvel, etc., something. You might be into multi-universe concept, parallel universe concept. Let us say this is Earth. What's the time now? 7:25. Okay, 7:25 it is. This is Earth. Let us say this is, we have 4, 8 here and 3. Let us say this is 483. Okay. These are all parallel universes. There is whatever variables that you are writing in the main area, okay, they cannot be accessed from the function. And main area doesn't even know that there is a function that exists. Main area doesn't know that there is something called n, there is something called fact, there is something called I. There are all these variables that are declared. These all are declared in function area. That's a separate world. Okay. Now, whatever you write in main area, you cannot access them inside the function as well. Okay, that's it. That's how it is. I hope you are understanding this a little bit. Let me show you a small proof of it. Now, what did I tell you? Let's say, let me call that fact only once. You see, everything is working. It is taking n value, 5 I'll give, 120 we are getting. Perfect. Now, I'll try to print that fact here. So print fact. Okay, you see? I'm going to come here, I'll execute all the lines. I'll again come back to 50th line. I'll execute this line. So fact means I should be able to see the output. I should be able to see 120 again. But here, if I run it, n equal to 5, you see, factorial equal to 120 I got. But when I'm trying to execute in line number 51, what am I getting? It is telling name fact is not defined, but we have defined it now. Fact 1, fact is updated to 120. What's happening here is, as I said, I hope you will understand this concept. Okay. This is function area. This is main area. Whatever you're doing in main area, function is not aware about it. Whatever you're doing in function area, main is not aware about it. Okay. Both are different worlds. Okay. So you will not be able to access factorial in the main area. You can only access it in the function area. That's what we call as a local variable. A local variable in the sense, you see, this fact is only present, is defined here, created here. It will be destroyed after all the lines of the function are executed. So it will be destroyed here. This is what we call as local variable, local to the function here. Okay, you can only access it inside the function. Done. That's it. So if I want to send any values or if I want to receive any values, okay, if I want to communicate in between the functions, there is no scope for it, no chance for it. That is where this calling line comes into picture. You see how you are coming to the function calling line? Sorry, function definition through the function call. When all the statements are executed, what will happen? You'll again go back to the function call, okay, whatever called it, right? So this is what we will be using. Let's say we will be using this as a portal. You will be able to travel through these two universes, two different areas through this portal. We'll talk about it. But for now, I hope you understood this part. Now let's close the function definition, function call part. Okay, then we can move forward with the next one. Okay, let me show you a small PDF material for it so that you guys can also go through that. Okay. Yeah, not this one. Where is it? I forgot my things. This one has full. Just a second. Give me some time. Old files we have. Let me check for functions. Yeah, this is my. These are pages of my book. I'll be happy to share these with you if you need. So see here. In function, we will be writing it only once. We will execute it whenever and wherever we want. That's what we call code reusability. That is the fundamental rule of programming we are following. Do not repeat yourself. There are four main parts of a function, that is function definition, function call, arguments, parameters, return keyword. Two are mandatory. We need to define a function. We need to call it in order to use it. So go through function definition once. I hope you will be fine with it. Function definition, we'll start with def keyword. Function definition will start with the def keyword followed by name of the function and a column. That is what we call as function header. We can also write some parameters in it. They are optional. We'll get to that point. And you can write one or more statements with a good level of indentation, but that indentation has to be consistent. That function name, parameters, body of the function is what we call as definition of the function. Now see function call. What is function call? Until and unless you call a function, it will never be executed. You have seen me. I'm calling it. If you call it, then only it will be executed. If you just run your code, doesn't matter how many functions you have. Okay, you can have thousands of functions. You can have thousands of lines inside them. Until and unless you call a function, it will never be executed. Done. That's it. That's it. Then you can call a function from main body or from any sub function or from the same function. That's what is recursion. We'll talk about it. Done. I hope you have gone through it, right? Done. Very good. Now, see here. Now let's talk about arguments and parameters. Now, what is meant by argument? What is meant by parameter? Whenever I want to send any values from main area to function area, if I want to send any values from main area to function area, I will be keeping that inside the function call. Okay, let me say I'll not be taking this n value in the function. I'll be taking it inside the main area. You see, I have the divider line that will help you get a good visual clarity. I'm taking n value from the main area. I want to send it to the function. You see, I'll be sending it as x also. Sorry, I'm sending it. I have to send it as n. I'll be receiving it as x also. Now, everywhere I'll be just changing it. You'll understand why I'm writing in this manner. Now, see what will happen is I'm taking input from the user from the main area. I'm sending that input to the function. That's a duplicate copy I'm going to send. If you are sending any values, that's what we call as arguments. Or you see inside print you have written something. Na? This is what we call as argument. Print is a function. Whatever values that you are passing inside of it, that's what we call as an argument. That's the name, technical name. You call it argument or you call it actual argument. Actual argument, multiple names, but the same meaning. Then values that you are receiving in the function call is what we call as parameters. These are what we call as parameters, technical term. Or this is what we call as formal arguments. This is what we call as formal arguments. Done. Now what happens here is, see, x will be assigned with the value inside n. For example, n value is equal to 5 I am going to give. So here the value will be sent. So x will be assigned with 5. Okay. Now I'm generating from 1 to x. That means 1 to 5. I'm multiplying it. I'm calculating the factorial. That's it. Now where am I taking the input? I'm taking the input in the main area. I'm sending it to the function. Now let me run it. Let me run it. So here n value equal to 5. We are able to get the answer. There is nothing, not an issue. Now you might ask, sir, earlier it was fine. Now why we are taking it? It's up to you. You see, in print statement, we will be entering the value. So we need to send an argument. Okay. Internal print implementation will be a bit different. Let me show a piece of it for you. You can right click here. You can click on go to definition. Okay. You see here, or let me click on, let's close this, maybe right click here, go to declaration, go to definition. Yeah, it's opening. You see, this is the file where, okay, Python is installed in my system. As you can see here, we have lots of code. This is the internal implementation of it. Okay, you can see here, it's not coming as a full file. You see, lots of code is there. This is the internal implementation. A developer sat there. He has written the code. He made sure we were able to easily Okay, use Python's functions and all. He made a simple print, okay, range, fact, etc. Everything, all of these. We are just sending a value that will be displayed on the screen. He has done that work. We are sending a value. So if your requirement, when you are designing a software, you want to send a value, you will send it as an argument. Otherwise, not needed. That's pretty much fine. Done. So if you want to send any value, you will send it as argument. How many values I'm sending? One. How many values you need to receive as parameters? One. You need to do that. And parameters are a duplicate copy. You see? Duplicate copy. That's why we call them as actual arguments and formal arguments. These are duplicate copy. Let me show you what I mean. So even, see here, I'm taking it as X. Here what I'll do is, okay, I'll make X as 0 and I'll be printing value of X. Now see the value of X. Okay. Now I'll come back here. After the function call is done, I'll print value of N. Okay. Let me write. This is function. So let me keep it as Fn. This is main. Let me keep it as main. Done. So see, N value, I'm giving it 5. I'm calling the function. I'll come to line number 43. I'll execute everything. X value became 0. X value, I'm printing it. I'll get 0. Fact, I'm printing it. I'll come back to the line 52. I'll execute line 53. So here I'm going to print the N value again. Now run this. Run this. Now see here, N value is equal to 5 I'm giving. You already know fact will be 120, but check this one. Value of X inside the function is 0. Inside the main is 5, right? Pretty cool, pretty easy for us. Done. Now let me change the name a little bit. You see, instead of taking it as X, I'm going to take it as N. Okay. Not X, N. I'll modify everywhere as N. Now can you guess what will be the output? Can you guess the 3 or 4 print statements? N value 5 I'll give. Fact 120 we'll get. First is the function value of N. Next main value. So what will be the function value and what will be the main value? Can anyone guess? What will be the function value and what will be the main value? Can anyone guess it? What will be the function value and what will be the main value? Function value and main value. Inside function N value will be, and inside main N value will be. N value will be. Let me run it. Just show to you. You see, if I'm entering N equal to 5. In the function, I'm making N as 0, I'm displaying it. Now, when I'm coming back to main, you see N is still 5. Now, how is this happening? How is this happening? As I told you at the beginning, if you remember, I gave you a very weird explanation or an example. I told you that this is what we call as function area. This is what we call as main area. Whatever you are doing in the function, okay, main doesn't even know that a function exists. Whatever you're doing in the main, function doesn't know even that. As I told you, these two are separate worlds. Any piece of communication between these two worlds, you will be able to do that through the function call only. This is kind of like a portal. Okay. Let's say that parallel Earth universe, this is some Earth 143, this is some Earth 738 or so. Okay. Here we have a person named N. Here we have a person named N. If the person dies here, that is what happened. N became 0. He is dead. Okay. Will he die? No. Okay. We have same person, we have two different people with the same name. That's it. You will also be having different people with the same name in your college or in your class somewhere. Some other person will be there with the same name. Okay. Your name is same, but your values, your address locations, everything are different. So what happens here is, let me give you the technical details of it. Okay. Let me not bore you with all these things. So here inside the main area, you see this is all main area's allocated memory. Main area, let's say N value will be allocated some 3000 for simplicity. This is where N is being stored. N value is 5. Now this is function area. For function, the memory, the variables, etc. and all are different because as I said, they don't even know that function and main exist. Function doesn't know main exists. Main doesn't know function exists. They don't even know each other. So here, when you're taking N, the name is same, but the memory location will be different. Let's say this is giving some 4000 memory location is allocated. Here the value that you're assigning is 5. Now, when you're making it 0, as I said, this is a local variable inside the function only. The value inside that function will become 0. Okay, your main area, your main value will be untouched. This is what we call as actual argument. And this is why we call as formal argument. These are duplicate copies. Whatever you do to this function variables, like values that you are receiving, it will not be affecting the original values. You can also call them as this is the original, this is n dash also. If you are being confused by the name, let nothing to be confused. Function doesn't even know main exists. Main doesn't even know function exists. They all are separated, two separate worlds. Any piece of communication, if you want to send any value, you'll send it to the function call. If you want to receive any value, we'll receive it through return keyword. We'll talk about it. So understood a bit about arguments and parameters. What is argument? The value we send to function is called argument. Values we receive from function is what we call parameter. Clear? Got some idea? Got some idea? Clear? Can we move forward? Right? Done. We can also pass multiple arguments and you will be getting a small error. Let me show that to you. Let's say n value I am sending, 6 I am sending, 7 I am sending, 8 I am sending. How many values I am sending? 4. How many values I should receive? 4. But if I do not receive it, I'll be getting an error. You say I'll run it, n value 5. You see, here it is pointing me out. It is saying factorial takes only one argument, but you are giving 4. Okay, if you are sending 4, you need to receive 4. Let me do that. Let's say A, B, C also. I'm not using them just to show you that you will be getting these errors. Okay, if you are sending 4 arguments, you have to receive 4 parameters. That's it. And the name can be same, memory locations, etc. Everything will be different. Done. Now moving on to the last part, the return word. Okay, let me remove all of this. This is all not required, or maybe I'll copy this and paste it here. You guys can explore it later. Let me remove all this complicated stuff. Done. Removed. Okay. Factorial. I'm going to pass the n value. Okay. Done. Now see here. Up to now, we have been just printing the factorial value inside the function. Inside the function. Now I don't want it to be printed here. I want it to return back to me. For example, if you look at our int function, it returns the converted integer. If you look at input, it will give you, okay, it will give you user entered input. It will return something to you, right? We are getting something written. It's not like being stuck in that file. We are getting the value back to us. So we want some value. So as I said, since if I try to print this fact here, we are unable to get it. You see, since that's a local variable, okay? That's a local variable. Will not be able to access it. So if we run it, we are getting an error. Sorry, I'll remove these things as well. Let me make it less complicated for you. Done. Let's run it. You see 5. That's it. We are getting error. Same. Fact we cannot access it because it's present here. I want to send that fact from the function area to the main area. From the function area to the main area. Now, how can I send it? Through something called return keyword. But again, look here. As I told you, if you remember, I drawed some strange lines again. Whenever you call a function, it will go to the calling line. So it will go to the function definition. It will execute everything. I'll draw it neatly. It will again return back to the calling line. It returns back. So it automatically comes back. So you don't even have to write it. So when it is coming back, it is not coming up with any value. So if I print it, what will I get? I'll be getting none. You see, I'm entering 5. It will print factorial, but it is coming back again. Here, this function returns nothing. None. Nothing. That is why we are getting it as none. Now what I can do is, I can write a small return statement here. Okay. Now whenever the compiler sees this return keyword, it will automatically return back to a calling line. Now you might ask, sir, what is the use of writing it? Automatically it will come back now when we are writing it. Okay. When it is coming back, it can also carry a value. Let us say I want it to carry the value of fact. That's it. If I run it and value is 5, factorial, comma, 120 will be printed. Next line we have written. I'm telling it to return back with the value of fact. So it will come back with the value of fact to line number 67. There I can save it inside another variable or I can directly display it. You see, I'm directly displaying it. So 5, I will be getting 122 times. Or not only one single value. I'll write a comma, I'll write multiple values. Let me write my name. Okay. Let me write XLR name. Let me write, let's say 15 days of training. So 15. Let's say today is fourth day out. So let's say 4. That's it. I can even send multiple values with it. Now let me run it. Enter 5. 120 Rajesh XLR 15 4. All 4 values will be written back to me in the form of a tuple. Collection of values. So it returns it in the form of a tuple data type in Python. Done. Pretty simple, pretty easy. Now let me show you one more thing. You can also write multiple return keywords. We will be also doing that inside recursion. So just to confirm that, you see I have written one more return. Yeah. If you observe everything grayed out, let me change the theme here a little bit. Maybe you will understand that one. Yeah, this looks fine. You see earlier it is looking like this. You see everything is glowing, very beautiful. Okay, very neat colors and all. But the moment I write a return keyword here, everything grayed out. Why it grayed out? You hover on it. VS Code is a very smart editor. It will tell you code is structurally unreachable. Why? What's happening? Let me show you. Let me run it as a compiler. Now n value I have taken it as 5. I'll go to line number 59 because I'm calling the function here 68th line. So 59 I'll go. I'll execute all the lines in the function. The first line of the function I see is return. What did I say? Whenever you come across return, you will again return back to the calling line. So these lines of code will never be executed. Will never be executed. That is why it's graying it out. It is telling me code is structurally unreachable. Generally, there are two situations where the function will return back to the calling line. First situation, whenever it executes all the lines of a function, it will return back. Or whenever it comes across return keyword, it will come back to its calling line. That's it. That's how simple it is. Clear? Done. Now let me show you a small, okay, notes for it. Then you can go through. So what do we call as arguments? Values passed in function call are called arguments. What do we call as parameters? Values that are received in function definition are called parameters. Now what did I say? Parameters are a copy. They are a duplicate copy of the original value. So parameter equal to argument we will do. Whatever you do with the parameter, that will not be affecting the original argument that you have. Okay, you see function call, the values that we are passing are arguments, values that we are receiving are parameters. That's it. Now let's talk about return. Now a function will return back to its calling line in two situations. Very important. Remember, in recursion, I'll be pointing out to these things only. You need to understand this. Then only you'll understand recursion. When all the statements in the function are executed, when the last statement is executed, the work of the function is completed. It will go back and it will execute the next line. Or whenever it comes across return keyword, it will also return back to the calling line. Now, you can also have multiple return statements. That's one thing. You have seen me writing 2 return statements in the same function. You can write if else and all. You can have multiple return statements. We can create a simple calculator. Done. And that return statement in C programming, generally it can carry one value. But in Python, it can carry multiple values in the form of tuple data type. That's it. That's it. Understood? Understood? Done? Yeah, generally, Arjun, we don't have much time. If you want to focus on learning, then that would be good. 2 hours, it's very short time, na? And I forgot to mention I even have presentations for them. Okay, if you guys don't want to look at the presentation, that's fine. I'll go with the brainstorming questions. You guys want the presentations? You guys want to present it? So I generally take a lot of time. I don't compromise on it. So, okay. Yeah, I'll give you the PDF. Don't worry. I'll give you these two are from my book. I'm writing a book. So do not share it anywhere else. Otherwise, I'll get a copyright strike for my own book. So I don't want to do that, right? Done? Done? Right, so see here, this is fine, this is done. Now, I hope you wanna see some animation, so let's go through that. First, let's get started with how to convert any given program into function. Okay, let's see that if there are any errors in the presentation, let it be. I don't use them that often. Okay, I don't teach basic actually. I go with dynamic programming, greedy. That's what I love generally. Okay, now see here, a function conversion programs we have. Okay, so program one, let's say how to convert factorial into a function. So what we will be doing first you will be writing factorial. Let me delete this one first. Done. Let me close. Do not raise your hands. That's giving me a pop-up. Okay. First, main area, I'll be writing a function. Okay. And run fact is equal to range, etc. and all. I'll be writing all of it. Done. So to convert a program into a function, what do you have to do? What did I tell you? Simply cut it out. Okay, give it a name, drop it there. That's it. So first thing, two mandatory parts, function definition. So first, go with def keyword with a space, give a name to this function. The name of the function is factorial, brackets open, brackets close, colon. Then whatever code that you have written, cut it out, paste it there. All this code, keep it there. That's it. Done with it. Function is created. If you want to execute it, you need to call it. So how to call it? What's the name of it? Factorial. If you call it, it will be executed. Function will be executed for the first time. If you do it again, it will be executed for second time. If you do it again, it will be executed for third time. Now same thing. Let's see how to convert sum of digits of a number into a function. Yesterday you have seen separating digits, reverse. Sum is also same. Sum is outside zero. You will take same logic you have. What do I have to do? Two things. I'll fast forward a little bit. Function definition we have def space name of the function colon. Okay, inside of the function you just need to paste this block of statements. That's it. Call the function, it will be executed. Done. That's how simple it is. Now all this is not required. Let me close it. Done. Now let's talk about what happens when you call a function. Okay, the visual representation of what happens. You see, we have two optional things. That is, you can send arguments if you want, or you cannot. You can send return value if you want, or you cannot. Okay, so let's see that. Let's see it. So this is for kids actually. So there will be a lot of penguins, etc. And also don't get excited about it. So you can ignore it. Okay, these were actually school kids. Now, first thing, we'll be defining our function you have seen here. This is the function I have written. Now, let's visualize what actually happens. My program will start executing from which line? From line number 7. That is my main area, and this is my function area. Okay. So what happens is function area is separated. You can see 1 to 6 there. That is our function area. I'll keep it down maybe. This is coming in my way. Okay, let's also, we will try to close this panel. Yeah, done. Yeah, it's still not removed. I need to know about zoom controls mostly. Done anyway, just leave it. I hope it's not blocking the view. Class is not showing in dashboard. What? I hope you guys are able to see the screen. Everything is fine, working fine. Can we continue? Okay. If any issue, just spam that chat box. I'll see. Now see here. First, your main area first line will be executed. That is seventh line of your code file. So seventh line of main will be executed. Okay, seventh line will be executed. So see here, seventh line will be executed. We are getting it. Now eighth line, what you're doing? You are calling the factorial. So where is factorial function? That is present in line number 1. So when you're calling it, it will come to line number 1. It will execute all the lines from line number 1 to line number 6. Now, once execution is done, means it is going to take number value, it is going to take fact value, it is going to generate all the numbers from 1 to n. After generating all the numbers, it is going to calculate the multiplication of it. You know how factorial works, so not explaining that part. So it will complete that execution. It will come after the loop, like it will print the factorial, done. Now, what did I tell you? This is the last statement of the loop. Once the last statement of a, sorry, last statement of the function. Once the last statement of a function is executed, the program should not end because I have other lines of code. It should again come back to calling line. You see? After completion of the function, control will again come back to calling line. Now, what is calling line? Eighth line is the calling line. So it will come back here. That line is executed. Now, line number 9. Ninth line will be executed. Again, in the 10th line, I'm calling the factorial function. It will again come back there. It will execute all the lines of code. I'm fast forwarding it since it is going to become boring. So everything will be executed. Once all the statements of a function are also executed, it will again come back to the calling line. Okay, that's it. When it comes back, it comes empty-handed. You are getting none. You can also return a value with it. That's it. That's how simple function is. Now again, you are calling it. Everything will be executed. Now again, it will come back. That's the last line of the function. So it will return back to the calling line. Now here, this is the last line of the main. This is where your program will end. That's it. Now let's see a scenario where we are getting none back. Okay, let's see this factorial where we are getting none, where we are getting none. Okay, let me not show you that penguin. I'll hide him today. Now see here, we have the function. Okay. Now, if you observe, I think, yeah. Now, same thing, actually, I should have shown you this one. As I'm calling it, everything will be executed. Okay. It will return with none, actually. It's not returning anything. Na? So, what is it going to come back? It is coming back with none, actually. So, it will bring none with it. Okay. So, are we getting none? Yes, you see, none will come back from the function. That's what you will get. Now, apart from that none, you can also write whatever you want. So let's go with argument and with return value. Okay, with argument with return value. Once you understand this, then we can happily get started with recursion. And recursion is one of my specialties. So this is all nothing. Right, so let me go ahead with that. You see, this is the code that we have, and I hope you can see I'm sending an argument and I'm receiving a return value. Divide it into two parts, main area and function area. So first thing, main area variables I'm showing. Function area variables I'm showing. As I said, both are two different worlds. Both values will be different. If you observe, in the main, I have something called num. In the function also, I have something called num. So both of them will be different. That's what I wanted to show. So let's get started with it. So see here. First, sixth line is executed. Sixth line of main is executed, will be printed. Next, seventh line is executed. It's asking me to enter num value. The memory location of it is 2050. Okay, I've entered num value as 5. Now, eighth line of the function is executed. Now, in the eighth line, what am I doing? I'm calling the function. Okay, and I'm sending 5 to it. So here, function is called. So I'll be going into the function area. And if you observe, fact is in the main, so it is memory location is 1050. Done. So 5 duplicate value is sent to num. So inside the function, that's a local variable. That's another person with the same name, but parents are different, memory locations different, everything different. So that 5 came to it. That's the duplicate value. Now fact equal to 1, fact etc. we will do. So we will be getting all the answer for it. So we are iterating it 5 times. Once we are done with 5, fact value is 120. Now if you observe, the same variable name I also have in function and in the main, but both are different. Both memory locations are different. You can observe here, right? So just to show you visually, I'm giving you that detail. Now once we are done with it, what we will do? We will again return back to calling line. So what is the calling line we have? Calling line we have is 8th line. Okay, so it is coming up with fact value. So what is the fact value? 120. So when it comes back with that 120. 120, now 120 will be stored inside the variable I'm giving. You can also directly print it, but I wanted to, okay, save it inside variable. I wanted to show that. Now, Function is executed. Eighth line is done. Ninth line it will come to. It will display fact value, that is 120. 120 will be displayed. Now next line, 10th line of main executed will be displayed. Now again 11th line, again it is asking me number value. In 12th line, it is calling the function. It is sending the value of num copy. So 6 will be sent there. Okay, you see 6 will be sent. It's a duplicate copy. That's it. So num, different memory location. Now the function will be executed. It will reiterate for 6 times. It will return back with 120. You see return fact. Fact will be returned. The value inside fact will be returned. That is 120. Okay. Main area fact and function area fact are having two different locations. They are just the same name. Two different persons with the same name. If anything happens to the other person, this person will not be affected. Okay. Keep that in mind. Yeah, understand it that simply. That's it. Fact, we are printing it again. 720, you will get it. Understood about arguments written, etc. and all. Arguments, parameters, written keyword, everything. Arguments, parameters, written keyword. What if happens if it was more or few arguments than expected? I've shown that to you. You will be getting an error. Okay. I've already shown that to you. You will be getting an error. Everything fine now? Now, let's get started with recursion. Okay. Let me drink some water. Okay. So we will start at 8:05. Just 4 minutes. Just 4 minutes. We'll start at 8:05. We'll start at 8:05. Done. Let me charge my device as well. We'll start at 8:05. And so meanwhile, you can take a good screenshot of this PDF if you want. You can take a good screenshot from my book, so do not use it anywhere else. So I'll get a copyright strike for my own book. So I would not like that to happen. Yeah, sure, sure. We'll do that. We'll close this. Right, guys, so we will resume again. Yes, again, short explanation I'll give it. So, whenever you want to execute a block of statements multiple times, you will write it as a function. Okay. Once you separate that piece of code, give a name to it, you will be able to call it whenever and wherever you want. You see, I've given the name as factorial. If I call it again, I'll be able to display it. Okay, so that's how simple it is going to be. See, I will copy this. I'll paste it multiple times. Doesn't matter how many times you try to execute it, you will be getting it done. So run it. Then in value 5, I'm giving, you see factorial, 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 I'm printing it. That's it, you are getting it. Now, while calling it, I can send some values into the function through the function call. Now, once the function is executed, it will also return back to this line. So during that process, it can also bring a value with it. Since it is not bringing anything, I'm getting none. If I write return, okay, I got you, I'll write one more comma fact, okay, two values, that's it. So you see, if I give 5, it is going to the function, it is executing it, it's printing factorial is 120, it is coming back, it is bringing me that fact value as well. So just to show you, we can write multiple values and it returns back. So we are printing it, we are able to display it. That's it, that's about it. That's about functions. That's the basic part of it. All of this is available in XLR YouTube. You can go through that. You can again rewatch it, right? And yes, all the lectures, they wanted me to prefer Python. I generally go with Java. I love Java, so they wanted me to prefer Python since first years are there, na? First years are there, second years are there, all over from Pan India are there. Python is a bit easy. It looks like kind of like a pseudo code, no? So that's fine. So those who are already like know basic Java, they can happily execute Python code. So Python people will not be able to execute Java code. You see, Java is good. So that's why. Kind of like pseudo codes, you guys can take it. That's how DSA will be. And ultimately, it's all about understanding how function works. It's not about the syntax. No? So leave it, understand the meaning. Doesn't matter which language I speak to you, Hindi, Telugu, English, okay, Tamil, etc. and all, Arabic, the meaning will be the same. The syntax changes, pronunciation changes, that's it. Done. That's it done. So let's get started with recursion. Let's get started with recursion. Now, what is recursion? Can anyone come up with the definition of recursion? Very good, very good. You guys are ready. I love that energy. Okay. A function, a function which calls itself, a function which calls itself again and again is called as recursive function. Okay, recursive function, and the process is called as recursion. If a function calls itself again and again, it's called as recursive function, and the process is called as recursion. That's it. That's what we have it. And now coming to recursion, you see, I follow specific rules for it. It's very easy. People generally complicate recursion a lot, so I don't have to think about it that much. So let me show you my PDF for it. So let's scroll down a little bit. Okay. Now see here, what are the advantages of recursion? Go through it once. I'll give you a good half minute to read all of it. I hope it will be enough. Go through it, read it half time, half minute. Today I'll be completing entire recursion. We'll see some 3, 4. So it might be a bit long. So you can stay and enjoy that recursion session. Okay. Done. I hope you have seen the advantages. Let's talk about it. You see, the first advantage is recursion is very simple. Recursive codes generally are shorter, simpler than non-recursive ones. Okay. They look very clean, very easy to use. Okay. But writing them is not that easy. So let's talk about it. And recursion is the alternative for loops. You will not be using any loop inside a recursion. We will make the function work as a loop. You see, the function is going to call itself again and again. So it works as a loop. So recursion is the alternative for recursion loops. You'll not be using a loop there. Okay, that's it. And recursion, see, it naturally follows divide and conquer. It naturally follows divide and conquer. Divide and conquer, the British rule. Given a bigger problem, you need to divide it into smaller sub-problems. Start conquering each one of them. Start solving those smaller problems. Ultimately, you will be able to solve the bigger one. Okay? So recursion solves a smaller version of itself until it cannot be divided further. Done. That's it. Recursion naturally follows divide and conquer. And where do we use recursion? Recursion, sixth point, see that? Where do we use recursion? Recursion is used in problem solving. Okay. You see, there are two things people will are a lot of confused about. First one is we have something called problem solving. We have something called programming. Okay. So what is problem solving? Given a question, problem solving in the sense you will be finding some sort of solution for it. Now, what is programming? Given a question, if you already know the solution, you're translating it. You're writing the code for it. So which one is more important or which one is more difficult? Given a question, coming up with the solution is difficult. So now what recursion does is, okay, it automatically checks all possible cases. You see, when you will be using recursion is, I'll give you a small note point. Okay. Whenever you see, there are two things here. You see, whenever you see all possible cases, whenever you see all possible cases in the question mentioned, or second thing, in the constraints, you will be having it as less than 40. The given input will be less than 40. Why less than 40? We'll talk about it. Now, let's talk about the first one. What recursion will do? Recursion will explore each and every path that is available. Recursion goes through all possible cases. Okay. And then it will find you the answer. Kind of like you can say this is a kind of like a small AI. Okay. So it checks all possible cases. It will give you the final answer. So what did I say? Where do we use recursion? We use it for problem solving. Given a question, recursion will automatically give you solution. Okay. Programming, given question, if you have solution, you will translate that to code. So problem solving is more important. Now, what did I say? Where can you use recursion? Wherever you see all possible cases or wherever you see if the input constraints, you see constraints we talked about now. Okay, constraints are less than 40. You can use recursion. You'll get that clarity. For now, I hope this is fine. You understood this part. I'll show you proof of each and every single statement I have written here. Done. This is okay. Understood this part. Advantages okay. A little bit. We'll see. We'll go with the proof of everything. So don't worry. Don't worry. Let me do one thing. Let me make the chart as host and co-host. Done. Done. I'll be removing if you are discussing anything else apart from the coding here. Okay. This is okay. Can we move forward? Can we go ahead with the next one? Simple yes or no will do. Simple yes or no will do. Yes. So couple of more yeses, then we can continue. Now see here, see the disadvantages. Go through disadvantages. Go through disadvantages. See the disadvantages. See the disadvantages. Now, recursion is difficult for beginners. You see, as a beginner, you will be finding it a bit difficult to understand or process recursion or write recursive solutions on your own a little bit. That's okay, that's fine. Recursion takes a bit of time for you to sink all the details in. Let's leave that apart. Now, see, recursion takes more time and recursion occupies more space most of the times. Okay, recursion takes more time to execute, more space to complete any task. Then why do we use recursion? You see, yesterday, like in the second day itself, we talked about time complexity, space complexity. What is a better code? Whatever code takes less time and less space to execute, that's what we call better code. But recursion is violating both of them. Sometimes recursion, like 70% of the times, recursion will take more time. It will occupy more space. Then why you are still using recursion? We are using it for its problem solving approach. Okay, you see, this is the roadmap I'm giving you as a beginner. You see, first recursion we have. Optimized version of recursion is backtracking. Okay, optimized version of backtracking is dynamic programming. Then you will get the memorization, etc. But giving you an idea, recursion checks all possible cases. Okay, so it is taking more time to check all possible cases and it remembers all the path. So that's why it takes more space. In order to optimize it, in order to avoid some unnecessary calculation, we restrict it in backtracking. Okay. And ultimately, you will be able to solve any question through dynamic programming. That's the optimized version of recursion. That now see the next point. You'll get clarity. I'll address all your queries at the ending. Recursion uses stack memory, which is limited. I hope you know about internal memory management, stack memory, heap memory, okay, permanent storage area, and all. Recursion uses stack memory, which is very limited. So while you are going through a code, while we are going through a program, you might run out of stack memory and it will result in an error. I'll also show this to you, don't worry. I hope this is fine. Done. Now see here, how to convert any function into recursion. You know how to convert functions, normal code into functions. Let's talk about how to convert functions into recursion. See, general idea, this is my idea. We will make the function call itself again and again by creating an infinite loop. Okay. We will be breaking the loop once we get our desired result. Now let's execute the line one and then I'll elaborate the line two as well. So see here, first task that I want to do is I want you to execute, okay, n to 1 numbers. I want you to display n to 1. Display n to 1. Means if I'm giving you 5, I should get 5, 4, 3, 2, 1. Okay, there's the sample input output. I hope you understood this one. Now what I'll be doing here is first I'll create a function. Let me call this function as gen. Okay, I'll make the function call itself again and again. Okay, I'll make the function call itself. So this is going to keep on calling itself again and again. So see here, I'm separating both of them. Done. As of now, I'm taking an input number, but it's not required. I'll not be using it as of now. But anyway, I'm taking an, I'll call the function. Done. See here what I'm going to do here or how the tracing will be. It's very easy for you to follow up. See, first I'm taking number. Let's say n equal to 5 I have given. In the next line, I'm calling the function. So I'll come here. Okay. I'll be executing all the lines of code. If the last line is executed, I'll go back to the calling line. But did the last line execute? No. What are you doing here? You're again calling the function. You'll again create another instance of it. So again, everything will be executed. Again, last statement, you're calling the function again. This process will keep on repeating. So you are creating an infinite loop. So what did I do? What did I say to you to do? Make the function call itself again and again. A function which calls itself again and again is what we call as recursive function, and the process is called recursion. You see, we made the function call itself again and again. Let me run this. I'm not using the 10 as of now. But if I run it, you see, if I enter n value 5, this should just get stuck there, okay? Because it's an infinite loop. It should keep on executing. But see what is going to happen. Okay, what's the output I'm going to get once I click on enter? You see here, it executed, it is giving me some error. It is saying that previous line repeated how many times? 996 times, or you can say recursion error, maximum recursion depth exceeded. So what's happening here actually? Generally, it has to go up to infinite times. But as I said, stack memory is limited, so it will execute for a fixed number. Like in my device stack memory, it is executing 996 times. In your device, it can execute a bit more. Okay. Now let me show you that it is executing. Let me write a small print statement here. Okay. Print statement, recursion. I will say rec. If I run it, if I enter any value, you see, rec. It should execute up to infinite number of times, but stack memory is repeated. So it will end in this format after executing for sometimes after utilizing all stack memory. Now this is not what I want. Now you see, I made the function call itself again and again. I don't want rec to be displayed. I want number to be displayed. You see, I'll be passing the number. I'll be receiving the number. Okay. I have to pass the number again. So here I'll be displaying the number. I hope I'm not being too fast about it. You see here what I'm doing? I'm taking a number from the user. Inside the function, I'm passing the number. I'm just displaying the number and I'm calling the function again. Okay. Now run it and value 10. I hope if you have observed, you see 10, 10, 10. I'm just showing you the execution there. After printing it, it should actually print it for infinite number of times, but recursion depth exceeded, so it ends. So do you want all tens? No. What do you want? If I give you n equal to 10, you want 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 or so. So what you have to do is, after displaying the value, when I'm going to the next iteration, I'm going to subtract 1 from it. Okay, I'm going to subtract 1 from it. Now you see here what's going to happen here. Let me run it and value equal to 5 I'll give. If I click on enter, now see, it was 5, then 4, then 3, then 2, then 1, then 0, so on. It should go up to negative infinity, but did it go up to negative infinity? No, it ended because of that stack memory. Done. Now, do I need up to negative infinity or do I need up to minus 993 also? No, I need it only up to 1. So what is my goal? I want 5, 4, 3, 2, 1. So what you're doing here, you made the function call itself again and again by making an infinite loop. While it is going through that infinite loop process, change the value. In the first iteration, it is 5. Next iteration, it is 4. Next iteration, it is 3. Next iteration, it is 2. Next iteration, it is 1. Now, you got a 5, 4, 3, 2, 1. Everything you already have. Now, you just need to stop it. So, how you will be stopping it? If n is equal to 0. Okay, then what I'll do? I'll simply write it as return. Now, what will happen here? Let me give you a small tracing here, then you will understand it. For now, first I want you to observe the output, then we'll talk about it. Enter it. I've entered n value as 5. You see 5, 4, 3, 2, 1. Let me print them in a single line. Comma end equal to space. Run it. N value 10. You see 10 to 1. N value 100. You see 10 to 100 to 1. Right? Now see here, as I talked about it, recursive code looks very clean. Okay, looks very shorter, looks very simpler than non-recursive code. Recursion is the alternative for loop. Do you see any loop here? Did I use any for loop or while loop to print multiple values? No. I made the function you call itself again and again, making it as a loop, right? Now, let's understand how this is actually working. Okay, let me give you a small idea about it. Anyway, I have the presentation for it. Let's go through that. Let's talk about it. Where is it? Yeah, now I copied it actually for you. Done. So what is recursion? A function which calls itself again and again is called recursive function, and the process is called recursion. Now, where do we actually use recursion? You see, we use it everywhere. Okay, in all nonlinear data structures, in all advanced algorithms, we use recursion. So it's very important for you to understand and master recursion. It will take you a little bit of time, but once you are able to visualize it, things will be a lot easier. Okay, so now see here. Now see here. Advantages, disadvantages you have seen. I'm not going to talk about it. Okay, let's remove that. All this is not required. Okay. Hmm. General idea, as I said, we'll make the function call itself again and again, creating an infinite loop. While that loop is repeating, we are going to modify the values. When we get the desired result, we will stop it. So see, yeah, we'll talk about it. Yeah, now into one. See, this is the code I have written. Done. Let me remove this raised hand as well. Done. Now let me show, see the comments. Yes, sir, we have. Don't worry, I'll show you. Hmm. Do not spam it. Wait for me to complete it. Okay, don't worry. You will get everything about recursion. If you still have doubts, then we will talk about it. Now, where is this? High floating meeting controls. Done. I hope this is perfect. Done. See, first, I'll be taking n value. So n value is equal to, let's say I'm going with 3. I'll show you some basic recursive calls. N is 3. That is the memory location of n. It's inside main. Now I'm calling the function gen of n. So gen of 3 it will be. So gen of 3, it will come back to this line. In the first iteration, first time I'm executing the function. You see, all the variables inside your function call will be stored inside your stack memory. So I'm visually showing that to you. If you don't know what is meant by a stack, we will talk about it soon. So don't worry. This is what we have as of now. Stack memory, we have it 2836. That is where it is stored. Stack means storing upon each other. Stack of books, stack of plates, we call it now. So upon each other. Done. Now see, if n equal to 0, is n equal to 0? 3 equal to 0? No, 3 is not equal to 0. Then what will happen? It will not execute the statement inside if. It will not be executing if. It will go with the next line. So what do we have here? Print n. So what is the value of n? N value is 3. So it is going to display 3. Very good. Now in the next line, if this line is executed, I'll go back to the calling line. I'll go back to the main function. But here I'm calling another function. So what will happen? Gen of n minus 1. So what will happen? Gen of n minus 1, that is 3 minus 1. So gen of 2, this is another function call. So one more time, I'm calling this function. Okay. Now what will happen is once this gen of 2 is completed and it returns back, then this gen of 3 will be completed. It will return back. So gen of 2, again, as I told you, n are duplicate values. Now you see here, our original main n value was 1010, the memory location of it. Now, in the first call, the n values memory location is 2836. You can see that it's stored inside stack memory. Every iteration will be stored there. Okay. Now, you see, again, I have to execute this function. And this time, another person with the same name, with some other memory location, 6528. This is the memory location of this n, that is for second iteration, gen of 2. Now, here I'll check if n equal to 0. 0 equal to 0, sorry, 2 equal to 0. No, 2 is not equal to 0. If statement is not true, so what will happen? It will go ahead and check the, like, it will go ahead and print it. So what do we have here? Print n. So what is the value we have? 2, display 2. That's it. 2 will be displayed. Now next line. You see, this is the last line. If this is executed, it will again go back to its calling line. But here we are calling another function again. So gen of n minus 1. That is gen of 2 minus 1. So gen of 1. Here I'm making one more function call. You see, first this function has to be completed. Then I'll return back to gen of 2. That function will be completed. Then I'll return back to gen of 3. That function will be completed. Then I'll return back to main area. You can see how they are stacked upon each other. They are dependent. Now gen of 1 we have. Again, a new n variable will be stored, 2000 location, the value is 1. Names are same, but memory locations are different. Every value will be stored inside memory separately. Why it will be stored, we'll talk about it. For now, I want you to observe it. Now, if n equal to 0, is n 0? No, 1 is not equal to 0. So if is not executed, then what will happen? Print statement. So print n, that is, what is the value of n? 1. Okay, 1 will be displayed. Now, gen of n minus 1 means gen of 1 minus 1, that is gen of 0. Another function call, you see fourth iteration it is. Now, these variables will also be stored. What is the n value? N value is 0. It is located at 1500 memory location now. Every iteration will be saved. Everything will be remembered. Now, here it will check. If n is equal to 0, is n equal to 0? Yes, 0 equal to 0. Then what will happen? Then what will happen? It will again it will execute if statement for the first time. So what do we have inside if? We have return keyword. So what did I tell you? Whenever return keyword is executed, it will go back to its calling line. Okay. So see, for the first time, we did not call another function. The function call did not work. Okay. Return keyword is executed. So we will return back to its calling line. So who called Zen of 0? Zen of 1 function called Zen of 0. So it will return back to its calling line. Now, when it is returning back, all the storage that is allocated to this function, okay, as I said, local variables it is, they will be created when we are when we are calling the function and the first line is executed. They will be destroyed if the last line of the function is executed. What I'm trying to say here is, you see gen of 0, the value of n is located 1500. When you are returning back, when that function is completed, it will be destroyed. Okay, function is executed, so it will be destroyed. It will be wiped out from the memory. That memory you are saving back, okay, for future usage. I see you came back to gen of 0. That's the last line. When the last line of a function is executed, then what will happen? You'll again return back to the calling line. Okay, who called gen of 1? Gen of 2 called gen of 1. Okay, now you see all the statements of a function are executed. So local variables, etc., and all will be wiped out from memory. You see, gen of 1 in stack memory also will disappear. Okay, that memory will be made use for future usage. Now, gen of 1 function is executed. Now, all the statements of a function are executed. It will again return back to its calling line. Okay, once it return back to its calling line, you see here that memory will be also destroyed. Now, gen of 3, who called gen of 3? Your main area called gen of 3. So once it return back, okay, that's it. You came back to the function that you have initially started. Now everything has been executed. Now your program will end. Okay. Understood this one. Understood this one. Understood the animation here. Clear? I'll make chat enable for everyone. Yeah, meeting group chat is enabled. Understood this one? Any doubt till this point? Understood? I know recursion will take some time to sink in. Okay. I hope you're able to understand. Now, did I say I'm a magician as well? Let me show you some magic. Okay. You see, n value we have, I'm getting n to 1 values done. I want to print 1 to n values. You see, the next program that we will do is 1 to n. 1 to n. Now, next program that we'll do is 1 to n. Okay. How can we display 1 to n? How can we display 1 to n? Any idea? Any idea? How can I display 1 to n numbers? N to 1 we have it. You see here, I'll run this code. I'll enter n value 10. 10 to 1 we are getting. 5, 5 to 1 we are getting. I want 1 to 5 or 1 to 10. 1 to n I want. So what can I do to get 1 to n? What can I do to get 1 to n? You see, I'll not be writing anything. You see here, observe very carefully. You see this statement? I'll swap both of them. Done. I've swapped it. Now I chanted some magical spell. Now you see 5 we have. So if I run it, this time what am I getting? If I enter 10, I'm getting 1 to 10. 1 to 10 here, 1 to 5 here, or you can enter 100. This time we are getting 1 to n, not n to 1. Now, how did this happen? Any idea? How did this happen? How did this happen? So it's very simple. Let me show you the visualization for it. You will understand it easily. So let's go through 1 to n. Okay. So you will understand what recursion generally does and why that stack memory is needed and all. Here, this is the point you will be able to understand. And yes, it is very difficult for you to follow that return statement. That's why I'm showing you a good visualization. I hope you have never seen something like this. So you see, I'm taking n value, n is equal to 3, right? Gen of n I'm calling. You see inside me, n value is stored at 1010. Now let me go through it. I'll be hiding this panel here. Where is that option? I forgot about it again. Yeah, hide floating meeting controls. Done. And value is located at 1010. Now I'm calling the function gen of 3. So the first iteration, okay, first time the function is called. Done. First time function is called. Gen of 3 inside stack memory, n is allocated, n is 2839. Okay, that is the memory. Both the names are same, but memory locations are different, values are different. Done. Now it will check if 3 equal to 0. Is 3 equal to 0? No, not. If will not be executed. You will execute the next line. What do we have here? I am calling a function. You see, gen of n minus 1 means gen of 3 minus 1. So gen of 2 you're calling. Now, we have one more statement after it, but it will not execute until this function is finished. Or it's very simple. You see here, n equal to int of input you're doing now. Once you take input, then only I'll call the function. No, next line will be executed. That's how it will be. Same thing only. Gen is also a function. Once it is completely executed, then only the next line will be executed. I hope you're understanding it. So see, gen of 2, I'm calling a function. I need to go through that function, then I need to return back, then the statement after it means then the print statement has to be executed. Done? Cool. I hope you are able to understand the visualization here. Now see here, gen of n value is allocated 6528 something. Done. Now I'm checking if n equal to 0. 2 equal to 0? No, not at all. So 2 not equal to 0. Then what will happen? It will not execute if it will go with the next line, that is gen of n minus 1. So I'm calling a function again. You see, gen of n minus 1 means gen of 2 minus 1, gen of 1. We have one statement after it, but once this gen of 1 is executed, then only it will execute that next print statement. So see here, gen of 1, I'm calling the function again. Function has to be completed. I need to return back. Then I'll execute the next line. Okay. Same concept with this input. If you are observing n equal to int of input. Once I take it, once input function is executed, then only the next line it will go. Na? Same concept here as well. Nothing to be confused. Okay. Now see, gen of 1 we have is 1 equal to 0. No, n is not equal to 0. 1 is not equal to 0. It will not be executed. Now the next line, gen of n minus 1. So what do we have gen of n minus 1? N minus 1 means 1 minus 1, that is 0 we have. So gen of 0 you're calling, again function calls. It will go ahead, it needs to execute it, it needs to come back. So gen of 0 we have. Now, I hope you're looking at the stack memory. I hope every memory location is different. The names are same, but memory locations are different. Okay. Now gen of 0 we have. Is 0 equal to 0? Yes. 0 equal to 0. For the first time it is true. So what did we want? We wanted 3, 2, 1, 1, 2, 3. Yeah. So we got 3 iterations. We got one number in each iteration. So 0 equal to 0, true. If it is true, then what will happen? Statement inside if will be executed. What do we have inside if? Return. Okay, return in the sense we are going to return back to our calling line. So what is the calling line we have? The calling line we have is gen of 0. So you see, return, it will return back to its calling line. Done. As I said, once the entire function is executed, the memory allocated for it will be destroyed as well. So what is the memory allocated to gen of 0? It only had one variable. For that one variable, 1500 memory is allocated. So that will be destroyed along with that function, like it was never existed. Okay, I snapped it and it turned to this. That's it. That's it, done. So you came back to gen of 0. Now you have one more line after gen of 0. What is that? Print n. So what is the value of n? What is the value of n? Anyone? What is the value of n? I'm opening the chat box again. What is the value of n? What is the value of n? Value of n is 0, na? Last iteration it was 0, no? Why 1? Why 1? Why 1? Because you are present in gen of 1 function. For gen of 1 function, what is the local variable n? Local variable n is present at 2000 location. So n value is not 0. That was in gen of 0 function. That was in 1500 memory location. Okay. Now in this particular function call in gen of 1, I hope you are seeing the stack memory as well here. Okay. See here. Stack memory. Gen of 1, what is the value of n? The value of n is 1. For every function call, it stores the value separately. It's not the same variable. So here, in that iteration, n became 0. I hope you remember actual arguments, formal arguments. Okay. This is the actual value for it. That was the formal value. So that was destroyed. N0, it is not even existing. Okay. Now see, if I display n, what is the value of n that is present here in gen of 1? That is 1. So 1 will be displayed. You see, now 1 is displayed. This how 3, 2, 1. We are executing from the backwards. 1 is displayed. Now this is the last line, no? You see in the function, this is the last line of our function. So last line of the function is executed. So what will happen? It will again go back to the calling line. So returns. By default, it will return because it needs to execute other lines na, after the function. So where it will go? Gen of 1, who called gen of 1? Gen of 2 called gen of 1. So it will return back to its calling line. Now when it returns back, gen of 1 entirely will be destroyed. Whatever memory is allocated to it, everything will be removed. So you see, Gen of 1 in stack memory is occupying 2000 location. So it will be destroyed along with it. Done. Right? So gen of 1 is executed. So what is the next line after gen of 1? We have another print statement inside that function. That print statement will be executed now. Now we need to print n. Now what is the value of n? What is the value of n again? What is the value of n now? What is the value of n? What is the value of n? You see, if you're looking at this, this is n minus 1. This is not the n that I'm talking about. Okay, not that one. What is the value of n? Value of n in this iteration is 2. You see, in gen of 2, n value is stored as 2. Okay, so I hope you're getting it. Every iteration, every number, every path it has explored, it will store it. Recursion stores it. Okay, so that's why we are getting it. Display 2 we are having. That's the last line. So again, it will go back to the calling line. You see, function, all the statements of a function are executed. What happens when all the statements of a function are executed? What happens when all the statements of a function are executed? It will again go back to its calling line. So who called it? Gen of 2 called it. Sorry, Gen of 3 called it. Sorry, my bad. So see, it will be destroyed completely. Done. Gen of 3. So that function is completed. Now it will execute the next line. So what do we have in the next line? N. So what is the value of n? 3 it is. So 3 will be displayed. So 1, 2, 3. Last line of the function is executed. It will go back to calling line. Who called it? Gen of n called it. That's it. That function is executed. Now everything will stop. Your program will end. Understood this one? Understood this visualization here? Clear? 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 Any doubt? Any doubt? Now you might ask, sir, why does it store all of it, sir? As I said, recursion is used for problem solving. Generally, I should have shown you this thing. Okay. Now, see here. Whenever you have a puzzle, or you might have seen this in your daily Sunday magazines also. Let's say we have a puzzle. We have this part here, maze puzzle. I'll start from one end. I'll take a right turn. I'll again go straight. I'll take a left turn. I'll take right turn. I'll again go. You see, I have a closed path. Now, what I'll do, I'll again come back. I'll again come back. I need to select one more path, which is not this one. You see, I'm going here again dead end. I need to come back. I need to go again dead end. I need to come back. I need to explore one more path. Okay. I need to keep on doing it until I come across a solution. Now, how you are able to remember? Like we remember all our previous directions, right? Recursion does this. Recursion saves each and everything that it has ever came across until you come across a solution. Okay? If you did not come across a solution in this path, it will again go back. It will again go back and explore one more path. This is what we call backtracking. This is what we call backtracking. You're tracking your steps again, backtracking. So recursion, optimized version of recursion is backtracking. Optimized version of backtracking is dynamic programming. That's it. That's how simple it is. Okay. As a beginner, try to understand how to convert a program into recursion. Slowly, all the details will sink in. Now, why recursion stores each and everything? Why recursion stores each and everything? It remembers all the parts that you have explored. Now, what did I tell you? Whenever we mention, okay, all possible cases, we will be using recursion. Or recursion is used for problem solving. Given a problem, it explores all possible solutions. It solves it. That's why it is used for problem solving. So whenever they mention all possible solutions, we use recursion. Or in the constraints, they will write 1 less than or equal to n less than or equal to 40, maximum 40. Okay, max 40. That's it. Whenever they mention it in this manner, you need to use recursion. So since recursion checks all possible cases, remembers each and every path it has gone through, that's why it is able to solve any given problem. Okay, done, right? Pretty much clear then. Can we go on? Can we go with the next one? Next question? Next program can we solve? No, I cannot answer this. I do not know anything. I will only take class. That's it. That's all I know. Okay. Right. So we have one more query. Let's see. Yeah, very good. 0. Fine. Now see, let's go with the next one. Now this time I want to get sum of all the numbers or product of all the numbers. Okay, let's write factorial. Last time we have seen factorial. Now let me go ahead with the same. Okay, I'll just change the name of the function, or let me leave the name of the function in this manner. Okay, what is factorial? What is 5 factorial? 5 into 4 into 3 into 2 into 1, right? Right, pretty easy. So I'm having 5, 4, 3, 2, 1. 5, 4, 3, 2, 1, I'm generating it. You say I'll keep them up and down. Again, if I run this, if I enter 5, I'm getting 5, 4, 3, 2, 1. Yes. What I need to do is I just simply need to multiply them. Okay, make a product of it. So let's see how it actually works. What I'll be doing is I'll write a small simple something n into gen of n minus 1. That's it. Okay, return 1. This is factorial function. Okay, let me print factorial. I'm returning it back. So comma gen of n. That's it, done. So now run it. Now run it. N equal to 5. What is the factorial? What is the factorial of 5? Factorial of 5 is 120. Pretty good. So if I enter it, I'm getting 120. Now we'll talk about how we got that code, but see how simple it is, how clean it is looking. We can also write it in single line. In Python, we can also do that. Okay. See how simple, how clean it is looking. As I show you, you see recursive code looks simple. Recursive solutions often tend to be shorter, simpler than non-recursive ones. Code is cleaner and easier to use. Yes, code looks very clean, very easy to use. I don't have any messy syntax of for loop, etc. Okay, fact equal to 1, fact equal to fact into I. Do we have any of this? No. Do you agree with the first 2 points? Yes. And recursion is the alternative for loops. Did I use any loop here? Did I use any loop here? No, I did not use any loop. Okay. Do we have any while loop or for loop? No. But still, if I enter 10, you see I'm getting factorial of 10. Code is shorter, simpler, cleaner, alternative for loop. Do you agree with these 3 points? Do you agree with these 3 points? Yes. Yes. That's how it is. That's how it is. Done. 3 points done. Now, as I said, recursion follows divide and conquer technique. Let me show you what I mean by that. Okay, let me show you for this one. For factorial of a number, we are asking it to calculate the factorial of 1. Okay, let's see that. You see, it's all mathematics at the end of the day. I hope you have seen this type of questions while you're schooling also, or even in your first year mathematics, etc. We need to calculate factorial of a number. Okay, product of all the numbers from 1 to n is what we call factorial. That's denoted by n factorial, n into n minus 1 into. If I write it in this manner, okay, if I write it in a function format, see, functions came from mathematics only. The base condition is if I reach 1 or if I reach 0 generally, that value is 0. Like if n value is 0, that's written only properly. If n value is 0, you have to return 1. That is the base condition. That is where we end. We'll also see base and recursive state once we complete this one. Coming to recursive function, if n value is not equal to 0, then n into n minus 1 factorial. Again, I'll call factorial function. I'll multiply n with it. You might have seen this format somewhere. I hope in some mathematics textbook. Let's go through that. You will understand it. Okay, let's leave it. This is not required. We don't have much time for that detailed explanation. This is the function I have written. Gen, I have just renamed it as fact for simplicity. Okay, let me close this panel and let me hide the controls as well. I'll resume it after the visualization. Done. So see here. Coming to n is equal to int of input. Enter a number. Okay. So entered number is 5. That is the number I'm entering. Now factorial of n is I'm calling the fact function. So fact function will be called fact of 5. You have called it. Now you're checking if n is 0. 5 is 0? No, 5 is not equal to 0. Then what will happen? You will not return 1. You will be returning n into fact of n minus 1. So what you will get is, I asked it to calculate factorial of 5. What it did is, it is giving me 5 into fact of 4. I asked it to calculate fact of 5. It is not doing fact of 5. It is doing a smaller version of itself. So it is going with fact of 4. Okay. Now we have fact of 4. See, 5 is an integer, but fact of 4 is a function. I need to call it again. I'll be coming back to the same print line. I need to again go ahead and call it again. Okay, fact of 4 I have to call it. Now, is 4 equal to 0? No, 4 is not equal to 0. Return 1 will not be executed. It will return 4 into fact of 3. You see, I asked it to calculate fact of 4. It is not calculating fact of 4. It is calculating a smaller version of itself. 4 into fact of 3. Now same thing will keep on repeating. Fact of 3 I'm asking. 3 is not equal to 0. Sorry. Then it will go ahead and return 3 into fact of 2. Now fact of 2. 2 is not equal to 0. You will get 2 into fact of 1. Now fact of 1. 1 is not equal to 0. You will be getting 1 into fact of 0. Now fact of 0. N value is 0. Yes, n is equal to 0. Now this time you're not dividing it. You see, what did I tell you? Recursion naturally follows divide and conquer, the British rule. Given a bigger problem, given factorial of 5, it will try to solve a smaller version of itself. Fact 4, fact 3, fact 2, fact 1, fact 0, until it cannot be divided further. You see, fact of 0 cannot be divided further. Okay, right? Now here we will be stopping. This is our base case. When you will stop, when you have achieved your goal. You see, fact of 5, 4, 3, 2, 1. Below 1 we have no number which we can calculate factorial of. Now what is factorial of 0? If n is equal to 0, if the number I have given you is 0, what is the factorial of it? Factorial is 1. So for n equal to 0, what we will get? We will be returning 1. You see, 1 we got. Now it will go back to the previous call. So 1 into 1. Okay. That is fact of 1. So fact of 1 is 1 now. It will go back again 2 into 1. That is the calculation for fact of 2. Now 2 into 3, that is 6. That is the calculation. That is the factorial value of fact of 3. Now 6 into 4. That is the factorial calculation value of fact of 4. 24 into 5. That is the factorial calculation. That is the value of fact of 5. That is 120. Understood? This is how it comes back. Okay, it will now all calls have been made. It recursion will go that deep. This is what we call tail recursion actually. The recursion depth that you are seeing, that is the recursion depth that it is talking about. It will go deep, it will keep on calling everything. Once the calls are finished, it will come back from there. This is what we call tail recursion, you can see. Recursion depth also. Every terminology, you can sync all those details. Now n value, you're getting 120 here. Done? Understood this one? Now let me also write it in a normal coding manner. So I'll not write it as gen. I'll keep it as fact. Okay? I wanted to show something a little bit more. Fact. Now, fact of n I have called. What is fact of n? You see, n value is equal to, I'm giving 5. N equal to 5. Now fact of 5, I'm calling fact of 5. You see, fact of 5 I have called. 5 equal to 0? No. It is returning 5 into fact of 4. So fact of 5, this is eliminated. We got 5 into fact of 4 here. Done. Now I cannot process this. Since this is a function, I need to execute it. It is completed, then I'll be able to display the value. Now fact of 4 we have. 4 equal to 0? No. What you will get? 4 into fact of 3. So fact of 4, for this you will be getting 4 into fact of 3, n minus 1, 3. Now again, this is another function call. I cannot execute it again. So what I'll do? I need to go through 3 equal to 0. No. What you will get? 3 into fact of 2. So fact of 3 you will be removing. That will be 3 into fact of 2. Now again, fact of 2, 2 not equal to 0. This will be replaced by 2 into fact of 1. Okay, again fact of 1. 1 is not equal to 0. This will be replaced by n into fact of n minus 1. That is 0. Now fact of 0. N is 0. Yes. Now the recursive function calls will stop. This is the base condition. This is the ending condition. This is where you have to stop. So recursive call will not be made. So what are you getting here? Factor of 0 is 1. So factor of 0, you are going to get 1. So what is the calculation you will get? 5 into 4 into 3 into 2 into 1 into 1. You will be getting 120. Okay. I hope you understood this one. Any doubt here? Any doubt? Instead of recursion, you can use a loop. But as I told you, recursion is used for problem solving. Okay, optimized version of recursion is backtracking. Optimized version of that is dynamic programming. So you can use a loop. We already did a loop yesterday. We are going with recursion now. So once you understand the concept of recursion, in future you can explore backtracking. In future you can explore dynamic programming. Answer, you see, it is returning back. It's doesn't even have, like, as I showed you, I did not include all that complex part. So n is a different variable now. Actually, this return also will be allocated some memory. So it is coming back here. So it everything will be processed inside that, okay, internally only. It will process everything. Once all the calls are finished, it will give us. So internally in the stack memory, etc., and all heap memory we have, now, their calculations will happen. I don't remember the exact word of it, but that's it. Okay. So any doubt anywhere? I missed, maybe missed some. I maybe missed something. Any doubt? Any doubt? Clear? Clear up to this point? Done. Now let's go through the last question in recursion that we are going to talk about. Okay. Let's talk about Fibonacci series. Let's talk about Fibonacci series. If you are someone who did not do Fibonacci series in your academic, that may be a bit tough for you, but I'll give you a little bit of idea for it. Everything I cannot start from scratch now. You should have some basic idea about programming. Then you can learn DSA, right? So Fibonacci series, see here. Fibonacci series generally starts from 0 and 1. You can start it from 1, 0. So this is what you can say. This is the fib of 0th term. Okay, that is 0. Again, this is fib of first term, that is 1. Fib of first term, that is 1, you can say. Now, fib of second term, you see f of 2, second term will be equal to f of 0 plus f of 1. Okay, or you can say f of 1 plus f of 0. The sum of previous two terms. So what is f of 0 plus f of, okay, 1. So 0 plus 1, that will be 1. Now what about fib of 3? Fib of 3 will be sum of previous two values, that is f of 2 plus f of 1, right? So f of 2 plus f of 1, if you calculate both of them, f of 3 will be equal to 2 here. Now what about f of 4? F of 4, it will be f of 3 plus f of 2. F of 3 plus f of 2. So f of 3 plus f of 2, f of 4 will be 3. Similarly, f of 5 will be 5, f of 6 will be 8, f of 7 will be, what is that 7 value? 13, f of this will be 21, 34, 55, 84, I guess. Yes, 84. So on, it will keep on repeating itself, right? Done. Let me just quickly type it. Done. So see, let me just write it. F of 5, f of 6, f of 7, f of 8, f of 9, f of 10 also. Okay. Done. F of 9, f of 10, and this is f of 11. Okay. Done. Now what about f of n? This process will keep on repeating. F of n is equal to f of n minus 1 plus f of n minus 2. Okay, I hope you are observing. F of 0 is equal to 1. So f of 0 is equal to 0. F of 1 is equal to 1. And rest of all the things, if f, the n value is greater than 2, it is going to be n minus 1 plus n minus 2. This is okay. This mathematics is okay for you. This is okay. This math is okay. This math is okay. Math is okay. Done. Clear? Can we move forward? This is okay. Basics of it is done. 89 it is. Sorry, my bad. I've been teaching from the morning, so it happens. Done? Right. So now let's talk about it. Now let's talk about it. Yeah, this is going to be a very big lecture now, so I hope you will stay up to the end. Let's talk about it. See here. We need to print Fibonacci series by using recursion. Okay, maybe the nth Fibonacci term or Fibonacci value that what we are printing. As you have seen, f of 0 is 0, f of 1 is 1. Any other value, it is going to be f of n minus 1 plus f of n minus 2. Okay. Now, this is the base call. This is the recursive call, as you have seen, whatever we have written. Okay. This is what the process will keep on happening. I've shown that to you normally. We'll come back to the code part. We'll come back to the code part. Let me write down the code for you. So now def fib of n, this is the function. If the n that you have given is equal to 0, you see, if n is 0, then what do I have to return? I need to return 0. If n is 1, if you are asking me what is fib of 1, if n is not 0, if n is equal to 1, what should I return? I should return 1. If n is not 0 and n is not 1, then what do I have to return? I have to return f of n minus 1 plus n minus 2. If not these two conditions, then else return fib of n minus 1 plus fib of n minus 2. You see, I told you now we can write multiple return statements and see how many calls you are making. You are making 2 calls. This is what we call binary recursion. By means 2. Okay. Binary recursion, like leave it that way. Okay, 2 calls you're making, right? This is our function area. Okay, this is our main area. N is equal to int of input I'll take. N equal to int of input. I'll ask the user to enter n value. Now here I'll print nth term. I'm printing nth term of Fibonacci series, not every term. I'll go with fib of n. Done. This is the function we have, and I hope you can see the statements here. I'll copy this. I'll paste it here. Done. Let me run it. Run this Python file. N value is equal to 5. I'll enter. What is the 5th term? 5 only. What is the 8th term? 21, as you can see here. What is the 11th term? 11th term is 89. What about the 12th term? 89 plus 55 or something. 89 plus 55, that is 144. So you're getting everything. You're getting the nth term, right? You're able to get it. Internally, it does a lot of calculation. Now, I told you, I'll be proving each and every line. You see, I have been highlighting them. Okay. Divide and conquer also you have seen. For factorial, I have proved it. Given factor of 5, it solved a smaller version of itself until it cannot be divided further. Done. This is also proved. Now, as I said, recursion is difficult for beginners. You guys already know that. And recursion takes more time and more space. That is what I'm showing you here. More space, you have already seen it. Where? Because it is storing every iteration. So that is why it is going to take more space. So every iteration is being stored. So that is also fine. Every iteration, more space is done. Stack memory, it runs out of stack memory. We have seen this one as well. It actually had to execute up to infinite number of times. But it's ended in the middle only, okay, because it ran out of stack memory. Now the only thing that I need to show is how it is taking more time and how it is also affecting the space value there. Now let me show that to you. Okay, so see here we are getting the value now. Now I told you one more constraint about this one. Okay, what is that? All possible solutions it will find. And where do you have to use recursion blindly? If in the question they have mentioned in the constraints that they will give you an input size of less than 40. Now, why less than 40 and why we can use recursion for it? Why not greater than 40? That is the question you need to ask. Let me show you why not greater than 40. You see? Well, so do the visualization, but for now, I want you to see. N equal to 10, I wanted the 10th term. See how much time it is going to take to execute it. So N equal to 10, I'll click on enter. I got it pretty quickly. Now let's increase the dose a bit. N equal to 20. I'll run it, count the seconds. Run it. You see, I got it pretty quickly. Done. Now N equal to 30. Now I'll click on enter, count the seconds. Run it. It took a nanosecond also, you see here, 30. It took a small half second, you can say. Done. Now n equal to 35, I'll say. Now see, it's executing, it's not stopped. 1, or I'll run it again. 35. See, 1, 2, 3. 3 seconds something. Good, good, sounds good. Now n equal to 40. You see, it's executing, it's calculating everything in the background. You see, last times for 10, for 20, for 30, for 35, I got it pretty fast. But n equal to 40, I'm not getting it much faster. Okay, why? Because it's calculating lot of operations in the background. You see, this is what we call exponential time complexity. For up to n value, it will be fine. Now it will suddenly shoot up. Okay, the number of operations that you need to do are more for the given n value. There comes a breaking point. That is what we call exponential time complexity. I've shown you graphs now, so this is a part of it. Now let me go with 43 or 45 also. Okay, 100 I'll not give. 100 I'll not give. 43 I'll give. You see 43, it will take lot of time. It's calculating. We'll go back, see all the stuff, then we'll come back. You see 9, 6 it is. It may even calculate. If I have given 45, it may even calculate that one. So let's continue. Let's see what's actually happening inside. Okay. So see this one. I'll close the panel here. I hope you don't have any doubts as of now. Done. So let me close this meeting control. Now, fib of n, we have n equal to 0, n equal to 1, else we are returning fib of n minus 1 plus fib of n minus 2, right? So let's say I have given you n value as 6. Now what will happen is I'm calculating fib of n, that is first time I have called it. So fib of 6 it is 6 equal to 0? No. It will check this one. Is 6 is equal to 1? No. Now what it will return? It will return fib of n minus 1 plus n minus 2. Okay. So what is n minus 1 plus n minus 2? If I'm calling fib of 6, it is giving me fib of 5 plus fib of 4 here. Now you see here. First, I have got two function calls. I have got two calls as written. I need to first complete the left call. First call it is fib of 5. Now for fib of 5, I'm calling it again. First left wing will be completed. This is what happens in backtracking and everywhere as well. So get habituated with it. So fib of 5, it will check 5 equal to 0. No. 5 equal to 1. No. What will be the return for that fib of 5? It will give you fib of 4 plus fib of 2. Sorry, fib of 4 plus fib of 3. If you want fib of 5, you need to calculate these two. Now again, the left one we need to go ahead. Okay, fib of 4. Fib of 4 is not 0. 4 is not equal to 1. Fib of 3 plus fib of 2. Again, left one. 3 not equal to 0. Okay, 3 not equal to 1. You will get fib of 2 plus fib of 1. 2 not equal to 0. 2 not equal to 1. Again, fib of 2 plus fib of 1 plus fib of 0. Now for the first time, left fib of 1 it is. 1 I know the answer. 1 is not equal to 0. 1 is equal to 1. What is fib of 1? We know that one. So fib of 1 is 1. So you see, we are getting 1 here. Now we are not making any recursive calls. Now the recursive calls are stopped. Now left wing is completed, we'll go to the right half. So now coming to right half, fib of 0. N equal to 0, yes. What do we have to return? We need to return 0. So return 0. Now if you add these two, these are all waiting, okay? Fib of 2, this calculation is. So fib of 2 is equal to fib of 1 plus fib of 0. Those two are calculated. Now you are getting the value for fib of 2 as 1, okay? Fib of 2 is calculated. Now the right half of it, that is fib of 1. Fib of 1 we need to calculate. So fib of 1, 1 is equal to 0. 1 is equal to 0? No. 1 is equal to 1? Yes. So you will be getting 1. For fib of 3, fib of 2 plus fib of 1 it is. So both are calculated, completed, functions are done. We got the value. Plus both of them, fib of 3 value we got. Left side is done. Right side we need to continue. Fib of 2 is, you see, we need to again repeat this entire process. We know fib of 2, we got it somewhere around 1 or so, but it will again repeat this entire process. Means whatever I have shown you, It will again divide that into fib of 1, fib of 0. It will perform that calculation. It will give you the number. So I'm skipping it for time's sake. You see, it will calculate everything manually. It will get that value. Now fib of 4 is 2 and 1. So add both of them. You got fib of 4 value. That is 3. Now fib of 4 is done. Fib of 3 you have to calculate again, the right wing of it. You see, we have already calculated it. But it will ask you to calculate again. Now fib of 3 will be again divided into fib of 2, fib of 1. Fib of 2 will be again divided into fib of 1, fib of 0. So all this entire calculation will be made again. Okay? And the result of that value will be 2. Everything it will do, it will come back to 2. Now, if you add these two values, you will get 5. Now you need to calculate the right half, that is fib of 4. But guess what? You have already calculated it. But it is going to calculate it again. Whatever you did in this left side part, you see all this fib of 4 part, you need to again execute it. Okay? Again run it. So you'll get 3. Now fib of 6 is equal to that 5 plus 3. You will be getting it as 8. Now if you observe, why recursion Fibonacci series or why recursion takes more time is, okay, you see here, in this particular recursive tree, how many times did you calculate fib of 2? Calculate, like how, just count 1, 2, 3, 4, 5. You are doing the same task again and again. You are doing repetitive work. If you are going to calculate the same number again and again, it is going to take more time only. Okay. Now, if you check fib of 3, so fib of 3 is same. So fib of 4 calculation is same. If I increase one value here, you see fib of 6 to fib of 5, fib of 6 to fib of 7, if I increase, I need to again calculate fib of 5, which is this long, You see all that tree I need to generate again. If I increase one more term, I need to perform another big tree calculation. Means how many times that f of 2, f of 3 would have been repeated. So why recursion takes more time most of the times is you're going to do the same calculation again and again and again. It is going to occupy more space for that. It is going to take more time for that. Okay, so that is why recursion takes more time and more space to calculate. And one more thing, in backtracking, we will be eliminating some of the unnecessary parts that we are exploring now. In dynamic programming, you will be remembering the value that you have already calculated. That's what we call memorization. Okay. So this is what optimization you will be learning in the future. Okay. So as I said, it will move forward a little bit. Once after a time, it will break out. Okay. Let's see if our champion has calculated it. Yes, he has calculated. Okay. You can also see the number of calculations. You see the correct way of using ChatGPT is, let me show that to you. Okay. Let me open ChatGPT. Let me close this. Yeah. You see, I'm closing this taskbar, close. Yeah. Don't want my personal chats now. See, I'll copy this one. I'll address your queries. Don't worry. I'll paste it here. It will give you all that unnecessary things and all. You're not doing optimization. That's fine. I don't want optimization. So see here, what I want is give me a table of number of seconds. Okay. It will take to execute n equal to 10, 20, 30, so on up to 150. Okay. Or let's go with 30 up to so on up to 100. So I want it to plot me how many seconds this is going to take. Okay, seconds, comma, operations also we will see. How many internal operations, function calls it is doing. Okay, this is how you have to use AI tools, not for the answers. To understand the answers, you need to try and use it. So see here. It will tell you that this is 2 power n, etc. Fibonacci. Okay, you can go through all of that, learn more a bit. Now see here, if n value equal to 10, I hope you all are looking. N equal to 10, how many calls will be made? 1024 calls. How much time it will take? Pretty fast. We have seen n equal to 10, I got it within no time. N equal to 20, 0.02. N equal to 30, we have observed a small lag. 21 seconds it is giving. It's not that accurate, but anyway. If I go with n equal to 40, taking 6 hours. If I go with n equal to 50, not much accurate, but you can relate that to a little bit smaller one. N equal to 60, 730 years. N equal to 70, N equal to 80, N equal to 100, 800 trillion years. You see, this is not accurate, but just giving you. Okay, give me an i5 processor, etc. Maybe i5 processor stats of the same. Okay, let's say it generally gives me a good answer for it. Okay. Hmm. It depends on how many function calls your system can handle. So that's what it is actually doing. So yeah, let's leave it. So I hope you have observed. If I'm increasing the value of n value to 40 to 50, it is going to take lot of time. And slowly, if you observe, it is increasing exponentially. This is what we call exponential time complexity. Okay. I told you now we'll be talking about time and space complexities as well. Okay. If I increase one more value, the number of calculations I need to make increases exponentially. This is why we call it exponential time complexity. And this is why you see, if I run it, for 10, I'll get the answer. For 20, I'll get the answer. For 30, I'll get the answer. For 40, it is taking a lot of time because it needs to generate all those trees. It needs to go to the bottom of it. It needs to calculate everything and come back to the top. Okay. It's a very big process. That's why it is taking a lot of time because it's calculating everything again and again. Now, where you will be optimizing this in backtracking, where you will be optimizing it in dynamic programming, this is the starting point. Okay. This it took a lot of time, so that's how it will be. You can use ChatGPT for getting that time. Understood this one? Understood this one? Any doubt in it? What is present, 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 and all? Understood? Understood. You have the lecture recorded as well. You can go back and watch it in YouTube. If you loved this lecture, do tag me on LinkedIn as well. Okay. Do tag me on LinkedIn. Do tag me on LinkedIn. My LinkedIn name is Rajesh Kumar Gandipilli. You can see that. Okay. Do post it on LinkedIn. Tag me and XLR as well. Right. Done. That's it. That's it for today then. Any doubts? I hope you understood this one. I hope you understood this one. Understood about recursion. Clear? Fine. That's it. That's it for today. I'll see you tomorrow with a new topic. Okay. Hope you loved it. Tag me on LinkedIn and post a small thing about today's lecture. Done then. Bye bye. That's it for today. It's been a bit more today. So I'll see you tomorrow. Bye bye.